Okay, can we start just with a little bit of background on Bioscope Technologies, the company, sort of the when, the why, just yeah, just some background.
Sure. I mean, the project started as a N2S project, our sister company, which is an ITAD company for recycling and of electronics and also of doing data erasure, that type of thing. And they were sending material to refineries, but didn't feel they was getting the full potential of the material back. And so they set up this project in 2018 to actually explore how you could actually extract base and precious metals from using bacteria. And that project lasted 3 years, and it was confirmed to be a fairly good project, as you may guess. If not, we wouldn't be here, I guess. Um, and then about 2022, really after the COVID sort of area sort of was going through, and afterwards they set up Bioscope, and Bioscope moved into the facility in Cambridge, and we started to develop the further research on how to extract some of the other elements other than copper, but palladium, silver, gold, etc. And I joined the company in September 23 to actually move it from a research place to build up to a commercial operation here in Cambridge. And it's been flying fully to get to that stage since since that time. And it felt that we needed to move it away from our sister company because it's very much a standalone. It's different. It acts like a refinery in that we're taking the circuit boards and everything and we're extracting the elements rather than just disassembling stuff or doing data erasure, etc.
Okay, and in terms of you mentioned early on that you didn't think that you were getting full value, if you like, from existing technology. So what are the limitations with the existing processes for recovering, I guess, the metals and okay, I don't know, bigger components? What from the PCBs? Where do they fall down?
Well, effectively, what you're relying on is either use third parties or you send the material to a refinery, and these refineries will sample this material by shredding it down, and then they'll do some sample preparation and some analysis, and pay you on how much gold, silver, palladium, and copper that's in the material. The problem is that most, like any business, they're wanting to get the maximum value out. And when you do analysis on the material, say here in the UK, through your own processes, quite often the results you get back with the refiners are slightly different. And that can be by material mix, or it could be that there's a bias in their sampling processes. So the owner of N2S at the time had this thing that there wasn't really getting the full value of that material back, and was suspicious, let's put it that way. And that led him to start this project. Whether it's founded or not, that's two matters of speaking, but that's the basis of the project. And I think that's quite founded in terms that if you are doing something yourself in terms of extracting the materials, then you know what that value is in that material. Plus the fact that the refineries only pay you for the copper, the gold, silver, and palladium. There's a lot of elements in electronic circuit boards that come from, the digital world, really.
And so, Bioscope, cut a long story short, Bioscope Technologies, you have developed yourselves then I think, two patented processes. First one is
Yeah.
bio-leaching and the second one bio-refining. So perhaps you can just talk us through each of those as to what they are and the benefits, I guess, that they provide.
Yes. Well, if you look at what our process is, it's very fundamentally different to the traditional methods. The traditional methods is using big, high temperature furnaces, use a lot of energy. They then move on to a hydrometallurgical process which is extraction through acids and cyanides, etc., and using a lot of water in the process. The process we use is actually taking bacteria that's naturally found in the mines in the UK and other parts of the world, and actually creating not a strain, but a mixture of strain of these bacteria, and we grow them to create a solution, a leachate, if you like, that then we add the shredded electronics to that and dissolves that base and precious metals. So then you need to extract that material. And we've also developed with our scientists here an extraction method using approtic solvents to take out the golds and the palladiums, as well as we plate out the copper and extract the tin as a salt. But the important thing of what the differences is ours is very low temperature. We're talking around about 70 degrees maximum for our processes. And the whole idea and what the scientists have built within our teams is a cyclical process, so that when we have the spent leachate that we've taken the tin and the copper out, we then actually move that back around to regrow the bacteria. And hence also when we extracted the gold and the silver and the palladium, the resultant liquid that's left, if you like, what some people would call effluent, we then distill, and then that solution is reused again in the process. So all we're doing is topping up. So it's very, very environmentally friendly and ecologically sound in terms of the processes. And it's at low temperatures. So we're not setting up our furnaces at over 2000 degrees. We're not using that energy, and we're not using vast, consistent quantities of water for cooling and cleaning and things like that. We use a little bit, but it's tiny in comparison.
And in terms of what you can tell me exactly where you're at, but as I understand it, you're investing across 4 PCB recovery and processing facilities. And I think you've also got a PCB shredder. I don't know if you have one of those per site or a roving one. Just if you can just clarify that, where you are at, I suppose, in terms of your infrastructure.
Yeah, we have sites that the main processing site for the actual process with the bacteria is here in Cambridge. We have some collection sites and preparation sites, but we have a shredding facility in our Midlands facility. So when the circuit boards come into, we need to prepare it. We can't just put a whole circuit board in. So we have a shredding facility there. We've spent some time and money on that to not just break up the material, but to be able to take it down to a point where if you just break it up very coarsely, then it's going to take a very long time for the bacteria to eat it. And we really want the reaction to happen fairly quickly. So we shred it down and then do some separation. So we take out as much of the fiberboard as possible from that material. So in effect, what goes through the process in Cambridge is probably about a third of the original material.
I'm sorry, I haven't asked. If you told me, I'm sorry if I didn't spot it. But how long does this process? You say you obviously you take away a lot of the board to speed up the process, or at least so it's not. How long does a typical cycle take, if such a thing exists, I suppose?
Yeah, well, the difficulty to the longer process is definitely the platinum group metals. If you look at traditional refiners, they'll pay you out in 90 to 120 days. We're turning this over in around about 30 to 60 days. So it's a considerably quicker. I mean, gold, all the refineries take out gold very quickly within, a day or so to a few days. And the base metals dissolve down fairly quickly, but then you've got to extract them in terms of that metal form. And so the bio process takes 24, 48 hours, but the extraction after that can take a while longer. But we're considerably quicker than the traditional methods.
In terms of just the bigger picture, I mean, how big is the global e-waste problem becoming? I mean, there must be some numbers out there, I guess, that you're aware of in terms of how much.
Yeah, it's the UN actually estimate that there's something like 62 million billion dollars worth of electronics that are not being recovered properly, and the market is huge. For the UK, data is quite difficult to ascertain in terms of really how much we are recovering, but certainly there are figures of around about 38,000 tons a year of electronic scrap is actually exported from the UK. I think that's a low figure. Um, we don't have refineries in the UK, so it all has to go um, to Europe, to the Far East, to the US.
And I suppose sort of following on from that, how big do you think therefore the opportunity is for yourselves both in the UK, and I don't know if you've got any plans to yourselves sort of look at overseas markets as well?
Yes, I think how I would describe that is that the market is considerable here. UK is a major contributor to the world in terms of usage and development of electronics. So we all know everybody has their own laptops, computers, mobile phones, TVs. You've got telecommunications, you've got data centers, you've got military, hospital, everything. The whole world runs around digitalization. And that obviously breaks down or it is replaced and renewed. And the opportunity for us is tremendous. I mean, at the moment, our current plant will look like to do about 1,000 tons or so. We have development processes in to considerably upscale that. And I think we are currently in the view of um, what's the term to use? I suppose it's preparing and analysing to see whether the market can take about a 10,000 ton a year plant of circuit board only. So if you think most electronics, the circuit board is around about 30% of the product. So if you then got 10,000 tons, that represents 30,000 tons, very approximately of the original material. And so the opportunity in the UK is phenomenal. If we then take that out to Europe and to the US and other places that are currently using traditional methods, the opportunity is very considerable.
And is that an opportunity you think you would like to control yourselves, or is it the technology something you could quite easily license to operators in overseas regions for them to do, or what are your if you have any plans as to how that would work?
Yeah, there's certainly some plans at the moment that we feel that certainly the UK we want to control and build that. There is a thought that we should license it out. This project is very modular, so you don't have to start off at 10,000. You could start at 2,000 tons. So you can you could put this package together as a modular process. And we've had a lot of interest in taking this project to other countries. So it's very much on the horizon that we could take advantage of that opportunity.
And in terms of the sort of the overall impact you think you might have, I mean, as I think you've mentioned a couple of times, the data center industry, the IT industry, sustainability is a big driver. I mean, I guess everyone is, but they're particularly under pressure because of there seem to be sort of energy hungry, etc. AI is going to add to that load. Just your thoughts, I suppose, as to the impact you think you will make when at least it comes to the end of the chain in the IT sector.
Well, if you look at what's happening in the world at the moment, I mean, what we're trying to achieve here is a low environmental impact process that extracts the elements that can be reused again. Um, The other thing is that if you actually look at a circuit board, and it doesn't matter whether it's coming from a data center or a mobile phone, they'll have 40 to 60 elements in there, and some of them are very critical to the Earth at the moment. If you look at um, the demand on materials and the worldwide situation on where a lot of the critical materials that, and I don't mean rare earths, but I mean critical minerals and materials that are using to build this material. That is in countries like Russia, China, and some of the more undesirable countries. So there is a certain amount of collaboration, but also protectionism to try and get sources of those materials for countries to source their own ability to rebuild this. So if you take, for instance, copper at the moment, um, everybody knows copper from your plumbing to it's in a circuit board to everything. But the amount of copper that's in an electronic circuit board is roughly 25, 30%. Well, the demand for that is expected to grow at the moment from about 25 million tons to 50 million tons by 2030, early 30s. That is doubling the demand. The primary source of that at the moment really is coming from the mines and the primary smelters. Well, the other big problem, the issue with that is that the new licensing for those mines is not coming forth. They're there in the earth, but the licensing for that technology, for generally for a mine like a copper mine or a tin mine, it takes about 15 years of licensing and permissions. And so a lot of the big mining companies are now looking for secondary recovery of whether it's copper, tin, precious metals, and the critical metals. So we need to look at how we extract that. So I think in a long-winded way of going around it, what I'm saying, the demand there is tremendous. And Bioscope can actually play their part, certainly for the UK and others, to extract that material and also look beyond that rather than the traditional ones the refiners pay of the copper, the tin, the palladiums, and the golds, etc. But look at some of the critical ones like the galliums, the germaniums, the hafniums, and other things that are in these circuit boards, and try and extract those. And that's part of our ongoing our R&D that we're working on.
And excuse my ignorance, but in terms of the extraction, sorry, the licensing, you explained sort of 15 years. Is that always been the case? And just because the expansion's massive, everyone, there's the pressure, or is it they increase because people have to go through more, should we say, hoops to, convince people that they're going to do it in a sustainable fashion, etc. Or is it just a standard time frame that's always existed?
I think in certainly in the more the world where is more conscious of the environmental impact of mining, I think there's a lot of hoops to go through to make sure that you're not impacting the countryside around it or minimalizing that. That's part of the problem that we have is that there are some countries that bypass that to a certain extent. Um, I'm not saying recycling is the total answer, but what I'm saying it'll become more and more important that we recycle this material and we recover it for what we call secondary use. And it generally is more generally a lot more environmental in terms of cost structure and impact to actually do that through secondary recover. If you take gold, for instance, we can actually extract, if you take 1 million mobile phones, we can extract around about 34 kilos of gold of that. And out of that, also that 1 million phones, you can get about 16,000 kilos of copper. Well, all those can go back into either manufacturing of some sort of product, whether it's particularly electronics. And that's very important for where we need to be in terms of recovery.
Okay, and then
And
maybe just
Bioscope want to pay part of that.
yeah. And in terms of the future, I mean, clearly you're busy, and whether it's right to call you an embryonic business, at least you're in the relatively early days. But do you have a roadmap to sort of develop other technologies? Do you want to broaden out your scope? Just anything you can share, I guess, as to how you see the company developing, or will this, what you're doing here keep you busy with all the potential to expand, or say you're looking at other research projects to develop other technologies?
Well, it's interesting you say that, because you might have remembered right at the beginning of the interview, I mentioned that we take out the fiberboard, the fiberglass. Well, at the moment, most people, if you put that through the traditional method of refining, that is burnt away. That's some of the areas where you start getting your POPs, the persistent organic pollutants, is when you burn the circuit boards. The research we've done, we're finding, because we're not using high temperature, we are not finding these POPs, but we also, that remaining material has a high amount of silica in the base. And we've got a research project on here at the moment where we're actually taking that silica instead of landfilling it, and that's still got a fair way to go. But if there needs to be a look at where else you can put these materials. So obviously, primarily, we see that a lot of our materials would go back into electronics manufacture, but there's some byproducts that can actually be used in other industries. And that's what we're trying to develop.
That's interesting because I do a bit of work in the semiconductor industry. I think I saw some news recently where somebody's using semiconductor waste to produce bricks. I think that's in Asia, but
Yes.
so yeah, no, it's fascinating to see
Yes.
the opportunities.
Yeah.
Anyway, it's been great to chat to you, and a really interesting topic, and sustainability clearly front and center for the industry, and great to see what you're up to. So Jeff, really appreciate your time today, and I'm sure we can
Yeah.
chat again in the future, see where you are got to. But for now, thanks very much. Thank you.
Yeah. Thank you.